We're going to spend some time remembering a formula that we learned a little bit earlier, that the area of a triangle is equal to 1/2 times the length of two sides times the sine of the angle between them. So we have this same triangle basically. I just drew in an altitude to this side B and I labeled it H for height. And then we know that the area formula would be 1/2 times base times height. We know that that's true. So if I am looking, I know that the sine of theta is equal to h over a because this is a right triangle. So what I can do is I can replace h with a times sine theta. So in any case, any triangle where I know this side, and the angle between them, I can always write the area as 1/2 times those two sides times the angle between them. Now, why is that really helpful when we're dealing with the area of a regular polygon when you're given the radius? Basically, if you're given a radius, then you don't really have to do a whole bunch of your right triangles, apothem split, anything else, because you basically are going to end up with this situation every time. So let's just show it in a few examples. First thing is find the central angle. So the central angle of a regular polygon is 360 divided by the number of sides. So this is a 45-degree angle. I know the radius is 12, so I now have a 12 on both sides. So if I want to find the area of this triangle, all I have to do is 1/2 times 12 times 12 times the sine of 45. And that's exactly what I'm going to do. So 1/2 times 12 times 12 times the sine of 45. And that gets me 50.911. So the area of one triangle in this problem is 50.911. Then I take that and multiply it by 8 because it's an octagon and there are 8 sides. And I end up with the area of the octagon is 407.294 units squared. Now, real quick, real quick, I'm going to show you that you actually can do the exact same thing with the apothem split. So if I have 22.5 here after I divide this by 2, I would need to find both of these values. So I can find the sine 22.5 equals x over 12. The cosine of 22.5 equals y over 12. So I would get x equals 12 times the sine of 22.5. Y equals 12 times the sine of 22.5. And then I'm going to show you on the screen right over here that when I type these things in, and I get x and y, and then I do 1/2 times, well, then I need to multiply x by 2 to get b. So I get 1/2 times what I have is y and b. Y is the height, b is the base. I'm going to get the exact same thing that I got doing 1/2 AB sine C or 1/2 AB sine theta. So I'm going to get 50.91168 and so on. So I could find the area of the triangle using apothem split, SOHCAHTOA. It's just when they give you the radius, it's a lot easier to use something different. Okay, two more real quick examples. I'm only going to use the 1/2 AB sine C or 1/2 AB sine theta because it's easier. But again, if you forget this way, you can use the apothem split and SOHCAHTOA. It's just in order to use SOHCAHTOA in this problem, you have to do both sine and cosine in order to get it. So both of these are 10. And then I have 360 divided by 9 because a nonagon has 9 sides. So I have a 40-degree angle on the inside. 40-degree angle. So 1/2 times 10 times 10 times the sine of 40 degrees. That ends up being 32.139. And then there would be 9 triangles in this picture. So I multiply this by 9, and I get the area is 289.254 units squared. One more quick example, a regular 15-gon. I'm not going to draw a 15-gon. That's too much work. But I can draw one triangle and then multiply the area of this triangle by 15. The radius is 6. That's going to show up on both sides. 360 divided by the number of sides gets me 24 degrees. So I have a 24-degree angle. So the area of this triangle is going to be 1/2 times 6 times 6 times the sine of 24. That ends up getting me 7.321. That's the area of this triangle. Then I multiply it by 15 because that's the number of sides. So the area of this 15-gon is 109.819 units squared.